in database to give them persistence behavior, then I need to have databases behaving with respect to object-oriented approach. So an object-oriented database. There are many variations to that object-oriented databases. So we will have to see that is another category. So you have studied RDBMS, and in advanced DBMS, what we did first was a distributed database of relational, a distributed RDBMS database. Okay, so using RDBMS, we spoke about distributions, and then we spoke about even heterogeneous distributed databases also, where you can have one place an RDBMS, another site I can have an object-oriented database, third site I can have a NoSQL database, fourth site I can have a document-oriented database, and so on. Such kind of heterogeneous databases also theoretically possible, but practically not yet commercially came out a successful product. Why? Because of, mainly because these products come from different vendors. So coming across with a common standard and making it work is the toughest challenge. So that's why it is not commercially fully successful till now. But homogeneous distributed databases are there available, and then it is working also. Okay. So these are the four different category what we are going to talk about. So obviously your project also will be running on these four lines. So you can get a question to develop a distributed database sometimes, or maybe to build something on a MongoDB, or to build something on an XML, or to build something on an object-oriented database. Okay, so your project part, what we will do is we will allocate you questions. If you come across some very good problem statements, other than the one what we have given, you can come back to us. If we find this is feasible and doable within the time limit, we will obviously work it out. So you need to, obviously when you are choosing a project, you need to think that it should be better than what you have done. It should be different from what you have done in your RDBMS project, because just merely repeating something similar to that doesn't make any sense. So I have done a library management system. Okay, let me try that using MongoDB. No, we don't want to do it that way. First of all, understand that why MongoDB was introduced. So understanding that difference from your traditional RDBMS, and then thinking about an application which requires such kind of data to be stored, unstructured data to be stored, then come across with a problem statement. So that's why what we will do is we will give you some problem statements which will be focusing on the other aspects of MongoDB rather than just merely storing data. Rather than that, it will try to explore the unstructured behavior of the data, see the complexities of those data, and then how MongoDB is managing into that. So such a way. So that's what should be your focus when you are trying to pick up a problem other than what we have been giving. Okay. So please understand that, because by doing the project, you are basically understanding that technology in depth, and you should be having a very good sound understanding of different types of databases. Is what the whole idea. Okay. So these four different categories, you will be given a question and teams will be formed. You can form the teams. We are expecting a team of 3 is what commonly used. So I don't know what ma'am has told about it, whether ma'am has mentioned it as 3 or 4, I'm not sure, but we will see. I will personally, it's better to have a 3-member team, because then
Rajesh, I had told students either 3 or 4. There are some
sure,
students who
sure.
wanted a group, a team of 4, so that is also okay.
Okay, okay. So in that case, you might have already formed a team. Share that information with us so that we can allocate projects and then probably give it to you so that you can start working on it. Already you are familiar with the distributed database approach. In soon you will try to work on XML as well as MongoDB, and then towards the end we will be working on object-oriented database. That's the plan. So, but at least whoever has got the other topics will be able to start, and then design part is kind of common in all these cases. So up to the midsum presentations, you can finish up the work. Actual implementation only purely depends upon what type of topic you got. Okay, so that's about the project part I'm talking about in terms of evaluations, in terms of what should be your focus. It should not be just just an extension of your DBMS projects what you have tried. Rather, you will be you might have to. I mean, you have to find out an application where you find the limitations of an RDBMS, where you cannot directly use an RDBMS to solve that problem, and you require something different. Then coming to any of these categories is what we are expecting. Okay, so that should be our focus. If regarding evaluations we have discussed, what type of documents you have to prepare and then submit, we will give you clear cut instructions. The first part will be a problem statement with what kind of uh, technology, I mean, like what, whether it is distributed or object oriented or whatever it is, and what specific platform you are going to use. When you say object oriented, there are many open source products available in the market which you can use. Or if you say NoSQL, whether it is MongoDB or something else, you're trying out document oriented, are you going to work with XML and distributed? What is the each site is going to use, how many sites? Those kind of details is what the first stage we want to get from you. Second stage, as I said, you need to build the design part. Even if it is an object oriented or document oriented, there are structures to be built first, that how I'm going to store each data, how each these data is going to communicate and other things. So that you have to submit in the second phase. And in the third phase, you will have to show us the demo of the executable project with a report. Report will be covering all the aspects of it. So you can make a small PPT and then initially brush upon what you have done and then demonstrate it. This is what we are expecting regarding the project. Okay, I hope I have made clear things on about project. So the next step will be from our side, we'll be trying to distribute you the problem statement. Before that, the CRs can please share the project teams list to us so that it will be easy for us to start off. Okay. So having said that, that is the project part is done. Now the next part is what's next after distributed databases. What we are going to talk about is document-oriented database. So as I said in the beginning, that we have seen RDBMS as an option to store data and work with it. Now, when internet became so popular, many things have changed. I mean, I'm sure you have studied computer networks. So in computer networks, we talk about a 7-layered architecture called OSI model. When internet came into picture, the whole OSI layered architecture has changed because people realized that there is lot many things changes and then we need to have a different approach. And then they came across like TCP/IP model. Something similar to that. When people talk about web applications and database as a backend, the RDBMS mechanism was quite working. But then what happens is people moved away from laptops and just started using mobile phones to a larger extent. And then the developers are coming with new mobile apps, applications, which is purely limited to mobile platform. That means not like a website I have developed for laptop as well as mobile phone, and then that is being streamed into a mobile phone also. Not like that. Rather, specific applications designed for mobile platforms or handheld devices. Handheld devices, when I say it can be a mobile phone, it can be a PDA, it can be a tab, whatever it is. So, in such cases, you need to think what is the kind of applications we are working with, like what is the kind of data we are going to work with. So as I said, WhatsApp kind of an application, if I'm trying to build, the kind of data what I'm going to get is completely different variety considered, I mean, compared to the one what I can think about AUMS, like a web applications, what you can think. Because there I'm using perfectly using a RDBMS like MySQL successfully that has been working extensible, large, I mean, scaling is possible in such cases, all those things. But when you see in mobile applications, the kind of data what you're dealing with is totally different. The way how you store it is different. And the programming interface what you're having, the Android app development platform is also totally different compared to a typical web application protocol suite what you are using in case of any of these applications like Java server pages or Java servlets or PHP kind of things. So which means that there are many changes with respect to the way how you see data, how you process data in case of mobile applications. So such unstructured data, how you will handle? And the answer was to have something different from an RDBMS, and then they called it as NoSQL database. database, or in general, it is called a document-oriented databases. So what exactly meant by document-oriented database is you are going to talk about documents as the base unit, and those documents can be anything. It can be a text file, it can be a binary file, it can be a image file, it can be an audio or video, whatever it is. So such kind of unstructured data, how you will store, how you will retrieve, how you will process it is what we try to talk in case of document-oriented databases. To have a better understanding, we are taking two examples from document-oriented databases. One called XML, which is the short form of Extensible Markup Language, and the other one is MongoDB. We'll talk about MongoDB later. We'll try to focus on Extensible Markup Language. When we say Extensible Markup Language, you might have heard about another markup language. Have you heard about any other markup language other than XML? Students?
So HTML.
HTML, Hypertext Markup Language. So that is one markup language which probably you may be familiar. Say, I don't know whether you had any course on HTML as such, but otherwise, as part of something, you might have studied HTML to a smaller extent of designing some pages using HTML. So what was the purpose of HTML? Why you have used HTML?
So for the front end components, like what all features I need.
Basically, in designing web pages, we have used HTML. So the purpose of an HTML kind of a language is to present the data in a more beautiful way. You have something called tags, and then each tag has got set of attributes. So these tags and attributes, which are basically predefined keywords, like what you have in C, int, main, void kind of keywords, what we talk about in C. Something similar to that, predefined tags, keywords, which is enclosed in angle brackets, is the basic part of an HTML. And these tags meanings are defined, and whatever you enclose within those tags will be displayed or will be presented in a specific fashion. So I can make a particular line of text bold or italics, or its color can be changed, its font size can be changed, all those things. So those are the operations what we use to perform in HTML. So HTML is basically designed to have a language to present the content, present the data in a more better way, smooth and efficient fashion, and colorful. Okay. Now, when you look into XML, that is also a markup language. So initially, when HTML, if you look into it, it has a very rigid platform. That means all the tags or keywords are predefined, attributes are predefined, values what I can assign to the attributes are also predefined. You cannot have any flexibility in that. So programmers started thinking about adding user-defined tags into it. So, but then confusion is like, how will you really work it? I mean, when you add a new tag, how everybody will come to know about it. So then you need to modify the entire interpreter, what is working with the HTML pages, all sort of things. So that leads to the development of a user-defined tag-based markup language, and that's what extensible markup language, or in short, XML. If you compare XML and HTML, both are markup language, but the difference is HTML, all the tags are predefined, all the attributes are predefined. In case of XML, it is user-defined. So when I say user-defined, the challenge is, see, I wanted to talk to say for example Vikas. So I'm using markup language to communicate. So then who are the two people who should know what is the meaning of these tags? Myself and Vikas, right? So we will sit together and then decide that these are the short forms. Say probably in classrooms and the things you people will be using that, right? About a faculty or about your one of your classmate, you wanted to pass something. You too probably will be knowing about the short words or some other different meaning words, and then you use that. Then the other fellows will not be able to understand what it is, but at the same point of time, you will be able to communicate properly. Same concept is what we are using in case of XML, which means that rather than presenting the data, this is used for sharing the data. Okay? That means when I wanted to share a data with somebody else, I generate a XML file in which this data is also embedded and then share it. Now, how will you interpret this data? Only I know what is the meaning of each tax. You know the meaning of the tax. That means the receiver, and we both only will be able to understand. Which means I have made up this language to make my communication secure. So when they started thinking about user-defined tags, finally they ended up creating a user-defined tag-based language, but that language is not being then used for presenting the data, rather it is heavily used for sharing the data. So network-based communication, people started using XML. Why? Because it is secure. You know the meaning of the tags, I know the meaning of the tags. An intermediate attacker will never be able to understand what it is if I have defined my tags properly. So which means that I will create a tag library, share it with you, so that when you get the XML file, you should be able to extract the data out of it. That has been done with the help of this tag library. Okay, so extensive markup language or XML is introduced with this particular way. So it became a language for sharing data over network in a more secure way. Initially, secure data communications, people were using cryptographic techniques. I hope you might have heard about the term cryptography. That means you encrypt the data and decrypt it. Encrypting the data in the sense you jumble up the words or jumble up the sentences and then send it to the other side. You know in what order you have jumbled it. So the other fellow will be able to put them back using this understanding. So something like that. That is what cryptography techniques used. But the problem is all those cryptographic algorithms are heavy. So you need to have more computing power, more resources to do that fast. And it takes some time also. Whereas on the other hand, if I could make an XML file out of the data and send it, it is easy, not so heavyweight processing requires comparatively easier way to do it. So obviously, this the popularity of XML being used as a medium to have secure communication has gone to a different level. Then, um, after receiving the data, you started thinking, okay, I can store the data also in using this mechanism. Okay, I mean, this thought has moved XML from a language used for markup purpose to communication purpose to finally as a database mechanism. That means for data storage. Okay, now what we do in databases, we store data in a specific format, and these database applications help me in retrieving the data, processing the data in a much easier way. That was the advantage of DBMS over files. Now, if you look into XML, this also provides the same thing. It gives you an option to store the data in the form of XML files so that nobody else will be able to understand what it is. They may be able to retrieve it, but they will not be able to understand what it is. And then processing it, you have tag library, so you will be able to extract information out of it very easily. So that way, XML became another alternative for DBMS, or I can say this becomes another type of DBMS. So that's how the whole concept of document-oriented databases or pure document-based databases are introduced with the help of XML. So this is how XML has evolved from a typical markup language, something competing with HTML, to a language used for secure data communication, to finally a language used as data storage purpose. Okay, so that's how the XML has evolved. So what exactly XML contains is again tags and attributes, but the only difference between HTML and XML is XML contains all user-defined tags. So the first process in XML is to define the tags and attributes. So for any pair of parties who are trying to communicate, they need to set up tag library and attribute library. So which means they will define the tags, meaning of the tags, they will define the attributes, meaning of the attributes, and possible contents what I can give it to the attributes. This is the structure of your XML document. Okay. So when you define the tags, you will say that this is the tag, this is the way it can use, and I can have tags inside tags, nested tags. I can have complicated contents inside that. All those things are possible. So the first part of understanding XML is to understand how will I store this structure, because if you can build the structure, then only XML can be used. So building the structure or representing this structure in specific format is the key part of XML. There are two ways to do it, or I can say there are two different types of documents I can generate. One is referred as a XML DTD, that is data type definition, um, which can be used to store your structure, or the other way is called XML schema. It's schema definition. The term schema, we are taking it from the ADBMS. So same way. So either I will use an XML schema file or a DTD file to represent the structure. Once I have a structure which is in the form of a DTD or a schema file, then it is easy to check whether a particular XML document is generated properly or not. What you do in a compiler, what exact operations you perform in a compiler. You write a program. Why do you compile it? What it does? Anyone?
So convert it into object code, like machine
Before that, it
understandable.
does one more thing also. Whether the program is
Optimization.
written syntactically or not, proper syntax or not, right? That's why you are getting compiler errors if it is not syntactically correct. So same way, when I have an XML file, I need to check whether it is syntactically correct. And syntactically correct with respect to what? With respect to the structure. And how will I represent the structure? Either in the form of a DTD file or in the form of a schema file. So I have parsing tools which will help me to check an XML file with respect to a DTD or a schema file and say whether the XML is a well-formed document or not. Well-formed document in the sense whether this particular document follows the structure properly or not. If it is a well-formed document, then there is another level where it will do parsing and interpret it. Okay. The first thing is checking its structure. Second one is parsing and then extracting the data or interpreting the data. So based on the tag library, what you have specified, you will extract the content out of it and then pass it back to you. So you need extra tools for parsing as well as interpreting the data. Okay, so those tools are required. But to generate an XML file, you just need to know what is the structure. Okay, so in the coming class, we will discuss about how DTD and schema can be written for a specific scenario. That means the basic way of writing DTD and schema, both we will learn. Once we know that, we can generate, I mean, if a scenario is given to you, you should be able to generate a DTD file or a schema file. Once you have a schema file, you can create XML files with respect to that. Say, for example, I'm saying I need to represent the details of students uh, in using XML. So when I say students, the next question is what type of information we will attach to it. We will have name of the student and probably his register number, which branch, which semester, all those things. Then there is address information that will have sub elements like house number, street number, locality, pin code, district, and other things. Then his contact details will have his phone number and email ID. And phone number needs to be a 10-digit mobile number. And an email ID should have @something.com.edu or something like that. So again, there are some restrictions. And then I say his CGPA. Then I am expecting a number to be there, a floating point number, like that. Then I need to know what is his key skills. So he will be mentioning some strings, which talks about different programming languages or platforms, what he is familiar with, something like that. So now when I mentioned, I'm saying about what are the type of data, what I'm going to store into it, and then what are the restrictions or limitations of the data, what you are going to store. Now, this information is what I'm supposed to represent using a DTD or a schema. So I will then try to define that there can be a tag called basic information where I will store his name, register number, semester, branch, all those things. Then I have another tag called contact information such as child elements like all this. Then I have address, then I have academic performance or something, and then key skills. So these are the details I'm going to store. So these many tags I require, these are the attributes it can take, or it can have child elements, all those things I will have to define. Okay, so that means what you will be getting as questions for exams is you will be given a scenario, and then you have to first generate a DTD or a schema, then write a corresponding XML file, because now when I define it for the student, any one of you can be represented using an XML file. So for example, Sriram's details, I'm storing in the form of an XML file. So his name, his register number, his branch, his semester, all those things will be in the first tag. Second tag will have child tags like his address details. Third tag will have his details of contact, and then another tag for his academic performance and so on. Same way, I can generate another XML file for someone else, like say for Sahana, I can make another XML file. So for each of you, I can have one XML file, and then I need to make sure that all these XML files follow a specific pattern, what is defined by the DTD. So that's where the DTD comes. So you will have one DTD for a particular structure of data, and then you can have any number of XML files following the DTD and for each specific instance. Okay, so you should be having mechanisms to define DTD, you should be having mechanisms to write XML file, and then you will have a mechanism of parsing it with respect to the DTD or schema and say this is a well-formed document. Once you have a well-formed document, you can send it to somebody else over network, they will download it there, they will have interpreter which will be extracting the data with respect to the library, tag library, what you have specified. What is the meaning of address tag? What is the meaning of street number tag? What is the meaning of house number tag, and so on, and then extracting the data out of it. So that's how XML works. So what we will do is we will teach you how to write DTD, how to write schema, and then how to check whether it is well-formed document or not using a tool, then using a tool to interpret the data. Okay, so this is what we are going to do in case of XML part. So if you are trying to build an application, then you can think about writing DTDs or schema first, when checking whether it is well-formed document or not, and then build the applications. So in the initial part, you will be writing the DTD as well as or schema with all the restrictions. Then you can have parsing part, and then finally interpreting part. Okay, so that's how it works. Now, uh, having said that, so the major two aspects will be about how to write DTD and how to write schema. That will be discussed in the next class, about what you mean by elements, what you mean by attributes, how we will write it, what are the possible values for certain attributes. It can take all those things we can do. And I was just saying that there can be only 10 numbers. So how will you define patterns for answers? All those things we will learn it. Okay, so that's the plan for the next class. So next thing will be once DTD is being taught, we will see how that parser can be installed in your machine and then start working with it. Okay, XML parser tools. Same way schema. So if you write, how will you use schema to verify whether a generated XML document is well formed or valid, kind of things. We will figure it out. Okay. So we spoke about two things, one about the project part, other part about um, how we start thinking different from an ADBMS perspective, and then talk about other types of databases. And XML we have taken as an example, and then we are working on it. Fine. Any queries on this, guys? Students?
No,
Do you have
sir.
any? So if you have been working with any web applications, you probably might have seen XML files are used for configuration purpose. I don't know whether anybody has really installed, probably for the RDBMS, you might have installed Apache Web Server or XAMPP or kind of things. So you might have noticed that there are some files which ending with XML, which are basically the configuration files. So here what we have used is XML is used to store configuration details, and only if you understand the basic meaning of those tags, you will be able to modify it. So basically, when somebody has to install it and then configure it, they need to understand what is the tag library associated with it and then use it. So XML is used heavily in many of these areas. Initially started off of using it as a secure data communication mechanism, then as storage and other side roles like this, what we have discussed. Okay, guys, then we will wind up here. We will discuss about XML in detail, about writing DTD and schema in the next class, and then parallelly we will start working with XML in the lab also. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.